Congruent triangles are triangles that are exactly the same. So when two triangles are congruent, they'll have exactly the same three sides and exactly the same three angles. The first property of congruent triangles we're going to look at is side, 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 as abbreviated SSS. So that means that this side AB with a single dash is equal in length to the side PQ with a single dash. And this side AC with this double dash is equal in length to the side PR with this double dash. Also, the side BC with this triple dash is equal in length to the side QR with this triple dash. So what we have is AB corresponds to PQ, AC corresponds to PR, and BC corresponds to QR. So all three corresponding sides are equal in length, hence the term side, side, side. So what we can say is that triangle ABC is congruent to triangle PQR, and the reason would be side, side, side. In this question, we want to prove that triangle ABC is congruent to triangle PQR, and hence we want to state the value of theta. So first we look at these two triangles. We are seeing that the lengths of the sides are similar. So we'll say that AB corresponds to PR, AC corresponds to QR, and BC corresponds to PQ. So for our proof, we'll write AB is equal to PR, which is equal to 6 centimeters. Then we have AC is equal to QR, which is 7 centimeters. And then we have BC, which is equal to PQ, which is 10 centimeters. Now all these sides were given on both triangles, so we didn't have to do anything to calculate the lengths of any side. So the reason for writing these things would be that the question gave them to us. So I'll simply put the reason as given for each one. Now that I've stated that the corresponding sides were equal in length to each other, I can make my statement that triangle ABC is congruent to triangle PQR. And my reason would be side, side, side. Now that the proof is done, we could go about finding the value of this angle theta here. So if we draw a line from the angle, it will touch this side 7 centimeters. So this angle theta is opposite to this side 7 centimeters. So we go to the other diagram to see which angle is opposite to the side 7 centimeters. So if I draw a line from the 20 degrees, it will touch the side 7 centimeters. Therefore, the 20 degrees is opposite to the 7 centimeters. Hence, theta corresponds to this 20 degrees. Therefore, theta is equal to 20 degrees. The next property we want to look at is angle, angle, side, which can be shortened to AAS, which means angle, angle, side. So this angle at A with a single line will be the same as this angle at P with a single line. And this angle at B with a double line would be the same as this angle at Q with a double line. So this angle at A corresponds to this angle at P, and this angle at B corresponds to this angle at Q. Also, we have the length of the side CB with a single stroke is the same as the length of the side RQ with a single stroke. So the side CB corresponds to the side RQ. So what we'll have is angle A is equal to angle P, and that was given. Then we'll have angle B is equal to angle Q, and that was also given. And then the length of the side CB is equal to the length of the side RQ, and that was also given. So therefore, these two triangles are congruent because of this reason here, angle, angle, side. So here I have triangle ABC is congruent to triangle PQR, and my reason would be AAS, which means angle, angle, side. In this question, we have to prove that triangle ABC is congruent to triangle PQR. Hence, state the value of AC. So when we look at these two triangles, we see that angle A corresponds to angle P, Angle B corresponds to angle Q. The length of the side BC corresponds to the length of the side QR. So we clearly see in two angles and one side on both triangles. Therefore, these two triangles are congruent, and the reason would be angle, angle, side. So now I'll make my statement. Angle A is equal to angle P, which is equal to 30 degrees, and that was given. Angle B is equal to angle Q, which is 40 degrees, and that was given. And the length of the side BC was equal to the length of the side QR, which is equal to 15 centimeters. And that too was given by the question. So therefore, triangle ABC is congruent to triangle PQR. And my reason would be angle, angle, side. Now to state the value of AC. So we look to this triangle, find the length of the side AC, draw a straight line from the side AC, and we'll go towards angle B. Hence AC is opposite to angle B, which is 40 degrees. So now draw a straight line from the 40 degree angle to see which side it touches. And it touches the side PR. Therefore, PR is opposite angle Q, which is 40 degrees. Hence AC is corresponding to the side PR. Therefore, AC is equal to 17 centimeters. So we'll have AC is equal to PR, which is equal to 17 centimeters. The third property for proving that two triangles are congruent is side, angle, side. Now notice the angle is written in between the two sides. So we'll have SAS standing for side, angle, side. And notice in my diagram, the angle A has one line here, which will be equal to angle P that also has the one line here. Notice that the side AB corresponds to the side PQ with the one stroke. Therefore, AB will be equal to PQ. And the side AC corresponds to the side PR with the double stroke. So AC will be equal in length to PR. Notice the angle is in between these corresponding sides. This AB corresponds with PQ, AC corresponds with PR, and the angle is in between the corresponding sides. Hence you state side, the angle is in the middle, and then the other side. Signifying the side, then the angle, and then the other corresponding side. Now if the angle was not in between the corresponding sides, you could not use this reason. So if we were to look at these two triangles, LMN and WXY, we would see that we have corresponding sides that are equal to each other. The LM is equal to the WX, and the LN is equal to the WY. But this angle M is equal to this angle X, but it's not in between the corresponding sides that we are given. And therefore, this reason of side, angle, side will not apply to these two triangles. Therefore, we cannot say that these two triangles are congruent because we don't have enough information to say so. So back to these two triangles, ABC and PQR. I'll write out my statement to prove that these two triangles are congruent. So we'll have the length of the side AB with the single dash being equal to the length of the side PQ with the single dash. And that was given on the diagram. Then we'll have AC with the double dash is equal to PR with the double dash. And again, this information was given on the diagram. So we write given. Then we'll have angle A is equal to angle P. And that was given on the diagram as well. Therefore, we have enough information to say that triangle ABC is congruent to triangle PQR. And the reason would be side, angle, side. In this question, we are asked to prove that triangle ABC is congruent to triangle PQR and hence state the value of theta. Now looking at these two triangles, I can see that the length of the side AB is the same as the length of the side PQ. So AB and PQ correspond to each other. Length of the side BC is the same as the length of the side QR. So BC and QR correspond to each other. Angle B is the same as angle Q. So these two angles correspond to each other. So I'm seeing the angle that is same on both triangles is in between the corresponding sides that I have on both triangles. Therefore, these two triangles will be congruent because of side, angle, side. So now I'll write out my statement. I'll have the length of his side AB is equal to the length of his side PQ, which is 9 centimeters. And that was given on the diagram. Then I have the length of his side BC is equal to the length of his side QR, and that's equal to 4 centimeters, and that was given on the diagram. Then I have angle B is equal to angle Q, which is equal to 20 degrees. And again, that was given on the diagram. Now that I have enough information to say that the two triangles are congruent, I'll make my final statement. So I made my statement that triangle ABC is congruent to triangle PQR, and now I'll state my reason being side, angle, side. Now we are asked to state the value of this angle theta here, which is the angle at P. So I'll draw a line from angle P to see which side is opposite to angle P. So the side QR is opposite angle P. So QR is 4 centimeters. I look on this triangle ABC, locate the 4 centimeters, and now I'll see which angle is opposite this 4 centimeters. So I'll draw a line from BC to see which angle it touches. And it goes towards angle A, which is 10 degrees. Therefore, theta is corresponding to the 10 degrees. Therefore, angle P is corresponding to angle A. And therefore, theta is equal to 10 degrees. The fourth and final reason for two triangles being congruent is hypotenuse leg, which can be written as HL, hypotenuse leg. Now the hypotenuse is always the longest side on a right angle triangle, which is the side that's opposite the right angle. If I was to draw a line from the right angle, it will touch AC here. Therefore, AC is the hypotenuse. If I was to draw a line from this right angle, it will touch PR. Therefore, PR is the hypotenuse. Now, on a right angle triangle, you would have the hypotenuse, and the other two sides, being AB and BC, are called the legs. So by having the single stroke on AC and the single stroke on PR, that means the hypotenuse on triangle ABC is equal in length to the hypotenuse on triangle PQR. So AC and PR corresponds to each other. Likewise, BC has the double strokes, which will correspond to the side QR, which has the double stroke. So the length of BC is equal to the length of QR. So BC would be one of the legs on the triangle ABC, and QR would be one of the legs on the triangle PQR. So what I have is the hypotenuse on both triangles being equal in length to each other, and one of the legs on both triangles being equal to each other. Therefore, these two triangles, ABC and PQR, are congruent, and the reason would be hypotenuse leg. So now I'll write my statement. So I'll have the length of the side AC, which is the hypotenuse, is equal to the length of the side PR, which is the hypotenuse on this triangle, and that is given on both diagrams. Then I'll have BC is equal to QR, and again, that information was given on both diagrams. Therefore, I have enough information to show that these two right angle triangles are congruent to each other. So I'll make my statement that triangle ABC is congruent to the triangle PQR, and now I'll write my reason, and my reason would be hypotenuse leg. So in this question, we have to prove that triangle ABC is congruent to triangle PQR, and state the value of theta. Now looking at these two right angle triangles, I can see that AC corresponds to PR. They both have the same length. AC is the hypotenuse here, and PR is the hypotenuse here. Then I have AB is 4 centimeters, and that corresponds to PQ being 4 centimeters. So this 4 centimeters is one of the legs of this right angle triangle, and this 4 centimeters here is one of the legs of this right angle triangle. So now I'll make my statement. AC is equal to PR, which is 5 centimeters. And that was given on the diagram. Then we have AB is equal to PQ, which is 4 centimeters. And that was also given on the diagram. So now we have enough information to show that these two right angle triangles are congruent to each other. So I have my statement that triangle ABC is congruent to triangle PQR. And now I'll state my reason as hypothenuse leg. Now I want to state the value of this angle here, theta. So I'll draw a line from theta to see which side it touches. So the side QR is opposite to the angle theta. And we can see QR is the side that the length is not stated. We have the 4 centimeters here, 5 centimeters, and this side the length is not stated. So when we come to triangle ABC, we are seeing the 4 centimeters, the 5 centimeters, and the side BC is the side that the length is not stated. So I'll draw a line up from BC to see which angle it's pointing towards. So the line is pointing towards this 30-degree angle. So that means this 30 degrees is opposite to the side BC. Therefore, this 30 degrees corresponds to theta. So theta is equal to 30 degrees.